Welcome back. So this is the lab part, and so chairs initially asked me to do a RIPE Atlas theoretical part and then a practical part. I was actually scratching my head on like what was the really nice thing to do for the practical part, and then out of nowhere there was this guy, Quirin, sending me an email saying, "Hey, I got this paper accepted to TMA and it's got RIPE Atlas, a nice RIPE Atlas part to it. Can we make a lab about it?" And I was like, "Whoa, yes!" I was so happy that, and for multiple things. First, for the help. And the other thing is, this is sort of the types of things that we like to do at the RIPE SCC. So out of nowhere, have these types of things just happen. So I'm super happy that Quirin has been preparing this lab. I think it's a great lab. So I'd like to give the floor to Quirin. And I want to
Thank you a lot. Yeah, I'm also really happy that this works, and I hope it will be a really fun lab because it's, as he said, it's about one of the papers in the conference. So you will really go from research question to how do I use RIPE Atlas to run through all the things and get it done. Obviously not in all the details, but following the big outline. So I hope this will be a lot of fun and also a good discussion. We want to spend a good time on discussion like RIPE Atlas. How do you do the measurement? Do you use this option or that option? Which one makes more sense for my use case? So shoot a lot of questions. So we figured what do we actually want to achieve in this lab? We want you to become familiar with RIPE Atlas, see what it can do, what you might use it for. And I think Emil already asked, a lot of people have used RIPE Atlas before, I think. And then we will see how to, from research question to measurement plan to execution, how to do it along the lines of this paper. And specifically, this will mean we will do DNS and traceroute measurements. How we will structure this lab is basically I'll give a bit of, Emil already gave a bit of background on RIPE Atlas itself. I'll quickly outline the research questions and the paper that we'll kind of follow along. Then we'll do the DNS measurements and the traceroute measurements. And in the end, we'll do some mapping to autonomous systems and IXPs. And I expect a good discussion on that, as we already had yesterday. The background is this paper. It was sent in a pre-reading. I guess most have flipped through it. You don't necessarily have to read it. It's just, if you have read it, you'll have a bit more background. So quickly, let me summarize what it was all about. It was about Apple push notification service, which I see a lot of Macs. It's per default enabled in iOS, macOS, watchOS, tvOS, iTunes and Windows, in everything. And it's always connected. And the nice thing it does, or not so nice thing it does, it uses client certificates to authenticate devices. And every time you connect to a network, it transmits that certificate. And that certificate is unique. So you can uniquely identify hundreds of millions of Apple users or devices which then kind of map to users. The talk in the conference will have more background on that. I just kind of fly over it for you as a background. What we then said is that actually a security problem? So we figured you could have two attacker types, a regional attacker, like a local ISP that wants to track some users, and we kind of did that as a proof of concept also in the paper, but we will not touch it today. And then we said a global adversary can actually some big global entity track a lot of APNS users. And this is what we will try to answer in this exercise and go along the lines in the paper. So in the detailed question, that would be, if you are this big global entity and want to surveil a lot of APNS users, how many networks do you need to eavesdrop on to see a lot of these logins happening? And what we did for that was to say, where are all the backend servers where these devices connect to. Then we measured paths to these backend servers, and then we map these paths to networks. And then we can kind of figure out how many of these networks, if you pick the top 10 or whatever, what you have to listen to see a lot of logins. That is actually only a part of the paper. And yes, every paper has a flaw, as I think Fabian said last year in the PhD school. And if you find them, there will be bonus points. This was a really quick outline. Is it halfway clear? Are there any immediate questions? Cool, good. Then the first step would be we need to find those back-end servers. So it's a huge service. There's like, as we said, there's hundreds of millions devices connecting to that service probably every day. And from passive observations, we know that they pick one of these DNS names to connect to that service. And we also know from passive observations, but also from the documentation that Apple provides, that it's in this rather big IP range where the servers will be located. So now the question is, how do we find all the backend servers that APNS uses? Any ideas?
So we do DNS resolving on the probes?
Yeah.
The local resolving? Yes, within all the...
Yeah. So the rough idea
So
would be...
Did everybody get that?
Or should I repeat it for the...
Maybe.
So the suggestion was we resolve these DNS names using RIPE Atlas, and then we get a lot of IP addresses. And yes, that's the rough idea. And that's what we will do as the first thing. Emil already asked you before the break to kind of pick a funny country you want to work on. So not everyone Germany and Italy. Do we have some clusters of countries? We figured it would be interesting if people sit together if they do a similar country.
Let's see how we do this. Maybe just go quickly. Who wants to do what country? Can you start?
The Netherlands, of course. South Korea.
Somewhere in Africa, Benin.
Okay.
So you'll join someone?
Big one.
Romania. Austria.
Iran.
Okay. Okay.
Brazil.
China.
China? Okay, cool. Okay. Sorry? Okay, just pick one. I just wanted to see if there's diversity, and this sounds like there's enough diversity. You guys all pick other countries, it will be fine. Does it work?
And if you have no idea, just join one of the
Yeah.
fun countries around.
Yeah. Okay. So yeah, maybe first step would be to see if there's enough probes in these countries, and you can get a little bit of sense in that table already.
Good, and that also takes us kind of to the prerequisites. I think we covered a couple of times. You all have a RIPE Atlas account, you are millionaires, and you have Python free. And did you download that GitHub? Yeah, it was in a preview. Excellent, good. Then we are ready to go. The GitHub also has the slides. I added them a couple of minutes ago, so you don't have to type up the links, but you can actually click on them in the PDF. Good, so then your first task is pick one of these, 1 to 50 for your country, and do a DNS resolution. Here's the link to do a new DNS measurement. And a general note, so some people will have done a lot of work on RIPE Atlas, some none. So to not make it too challenging for those that have done none and too boring for those that have done a lot, we kind of have two tracks. So if you say you've done a lot, your challenge is to do all 50. If you say, hey, this is new, just do one of these 50.
Okay, yeah, and I forgot to mention at the beginning. So this is what we like to do in a lab. If you just want to explore the system with your million credits, go knock yourself out. We really like just to use it. And the other thing, Alistair told me that the lab from yesterday, now also the exercise 6 has a RIPE Atlas component. We worked a little bit on that. So that is also something that people can now, or preferably later, also take a look at. So, but for now, knock yourself out on this, hopefully, or something else. So we take 5 minutes.
Yeah.
And of course, we are here for questions.
Running to 12. Yes, it's 12:30.
Oh, yeah, no, oh, yeah, we have a breakout session in between, so 12:30. Yeah, 12:30. Yeah, that's good. Okay. Maybe we can ask machine of ID so we can actually show them on the screen.
We just
Yeah.
maybe a bit long to call them for the room.
Pen and paper. Pen and paper. Pen and paper. Okay, this is just one. Yeah.
No, but I'm trying to use this online to switch out to the previous one.
Not done, it's still running.
Ah, yeah, the measurement will take.
Just show how you do the measurement.
Okay, good. So we'll quickly discuss on. Some people ask questions, and it's exactly those questions that we want to discuss. Like, should we do resolve and probe or not, and all that stuff. So, should we start with the web front end or?
Yeah, I think.
So then we just kind of run through how we would do it. So we would say DNS, and then maybe you talk through the.
Yeah. So one thing I noticed is that it's the interface might be a bit confusing for especially if you're not into DNS much. So the target here for DNS measurement is the actual DNS server that you're targeting. So that's not the thing that you want to resolve. But there's two options here. That's use the probe's resolver. So and resolve on probe. Resolve on probe is if you want to resolve a hostname that you put in as a target. This is a bit confusing, but that's not the option we want to use, because we actually want to use the resolver that the probes are using. So the local thing that is. So we click use probes resolvers, and magically we get less options, which is what we actually want. So here you say the DNS measurement I want to do is an IPv4 measurements, the query class, that's a weird DNS thing. A is hostname to IP address lookups, IPv4 address, quad A's would be IPv6. The query argument is actually the hostname that you want looked up. So so you put the hostname in, so 7-courier.push.apple.com. Then you scroll down. There's advanced options. I don't think we need to look at them. Maybe
Maybe you quickly go.
Yeah. So one thing that is important is include the abuf. The abuf is the thing in DNS that actually has the answer. I think it's on by default, so we don't need to do anything. But don't check it off, because then you cannot. There's all kinds of. If you're into DNSSEC, you have all kinds of DNSSEC bits you can set. You can do fun things with, if you control the DNS server that you measure towards, you can include the probe ID in the query that you do. So if it goes through something, you can actually see. There's a whole lot of fun you can do with it. A spread is an interesting one, because.
Question about the probe ID, it also always prevents a unique timestamp, right? Or is it only in
Does it prepend a unique timestamp?
Yeah, it does. Timestamp and the property. Yeah.
For this one?
Yeah.
Okay. There is actually talk about having some sort of macro language here, so you can actually specify in the host names that you specify that the probe at that point will include a timestamp or a probe ID or something, or but the spread is interesting because usually these measurements are done at a specific time, plus or minus 14 seconds, if I remember correctly. But sometimes you want to spread this measurement out. So say I have 50 probes that I want to measure during this interval, and then you just give it a wider spread, so the probes select randomly within this spread when they actually do the measurement. So, and the interval that you specify is just how often they do this after they sort of created the offset of each other. Yes, if you scroll down, there's probe selection here. The wizard is actually a world map where you can get all kinds of interesting things. The new set manual, I think, is the most interesting for research purposes.
Should
so
we do that?
Yeah. The type, so you have specific probe selection types. Area is a weird thing that selects parts of the world. Country is the one that we would be using. Prefix and ASNs are other interesting ones that you could probably use in research. So for country, you just start typing country name, or you put a country code in here. Bangladesh, yes, let's do Bangladesh. So it puts the country code in here. Yeah, let's pick 50 probes. You could add, so for instance, you could say.
There was actually a question how to say I want all probes in a country.
Yeah.
I didn't know a good answer except
-1.
1,000.
-1.
-1 didn't work, I think.
Ah.
It's not.
Okay, then we need to look into that.
But 1,000 seems reasonable because you can't do more than 1,000 anyway.
Yeah. And here you could, for instance, add system-IPv4-works if you only want the probes that have a working IPv6, IPv4. So let's just add 50 probes to Bangladesh. Then we say this is a one-off. And now measurement API is compatible. If you scroll in the box, this actually has the thing that you need to specify for if you want to do it through the API. So that's really really nice.
So that's, for example, how I did it in the paper. I just configured it once in the nice web UI, and then copy-pasted that, put it into a shell script, and did it for all kinds of countries and whatever. So that's a really nice way to use it, I think.
And I think we can actually look at if you just take the form off of here and just specify a measurement ID. I guess you all used measurement IDs that started with 89260. And then 2 more numbers. Does anybody want to specify a measurement ID that we can look at here? Anybody? 25? 25. So.
Excellent.
Yes.
Even a nice title.
Let's see. Get to the probes. You did Taiwan. Okay, nice. And we'll have. Oh, we can put it on a map. So. Yeah, these are the probes you selected. I guess all our probes are in Bangkok. No, or Taiwan. In Taipei, probably. And this actually shows the RTTs they have to their resolver. So that's not useful for this exercise.
As long as it worked, it doesn't
Yeah,
really matter.
so it worked.
And you can also now see the general information, like which one was resolved, number 20 in that case. Include above true. Yeah. And only 5 out of 10 probes did actually do the job.
And here you can actually see that the specification was country Taiwan, number of probes. So everybody has, or I hope that many, how many have a successful measurement specified? Okay, do people need more time to specify a measurement? Okay, so
I don't know.
shall we?
I guess we can continue. If you didn't have a successful measurement, you can use the one I have in the slides, or use maybe this one. So there's plenty of measurements that you can always build on if you couldn't do it, but it's otherwise take a minute and do it. It was really easy when you know which one, or once we had discussed all the options.
But I have to admit, the interface is a bit tricky if you don't know that what check marks you have to check. If you have suggestions on how to make that better, that's good feedback.
Good. And we also saw that was 100 credits wasted, so you'll have a while to go.
You're not a millionaire anymore.
But where do I see the results? Where do I see the IP address?
Okay. We'll get to that now.
Yeah.
There's a result tab, but there is nothing unless I have to download it.
We'll do just that now, the result of the DNS query.
Yes.
Yeah. That's unfortunately not that easy. But we'll get there. So I think we discussed those parts, like what probes did you choose, how many per country, as you all just picked one country. I think that was straightforward. The detailed DNS settings, we didn't do a lot of advanced stuff, no DNSSEC, so that was also rather simple. And this was kind of the question, did someone do it for all 50? The advanced user track, excellent. How did you do that? Yeah. So you just copy that thing at the bottom, do a wrapper, count to 50, and you have 50 jobs. Yeah.
Is there a way to see which resolver a probe uses?
I guess it could be in the above pointer Q probe.
It's in the measurement. We can look at the measurement results. It is the destination address in there, if I remember correctly, and we'll probably see that how many people actually use Google's 8888 as resolver, for instance, which to me is pretty shocking to see how big that thing actually got. So
I was wondering, is there a way to pre-filter out people using 8888? Because obviously you can use a lot of credit for making DNS requests that you don't particularly care about.
I like that idea. It's not implemented, but during our last hackathon, we had a DNS hackathon. There was people who actually were mapping, like, what are people actually using as probe resolvers? What's the IP address? Like, if you look, for instance, at Google, it's a big resolve farm. It's not 8888. It's not a single thing. It's anycasted. It has a lot of backends, so you can actually measure probe to resolver. So you have that IP address, but you can also measure, if you control the DNS server on the authoritative, you can measure where it comes out of the Google Cloud. So you can actually map that for like specific regions, and that's map the capabilities of these resolvers. Do they do, for instance, for privacy, there's now QNAME minimization, which is you don't ask Google all of the question that you want to know, or you don't ask .com all you want to know. You just ask .com for the next label. So they don't have to know that you want this specific thing. You just ask the next. Like these capabilities, you can actually map that using RIPE Atlas, and there's measurements in the system already doing that. So you could create probe tags or like some type of thing. Probe tags would be difficult, but you could create a database for yourself, for instance, that parses these results. That's how I would do it. It's a bit more work than having it in the system, but does that answer it?
Good. Then we'll move on. In the slides I always put like some measurement from the paper, some measurement I did recently, so if you couldn't do it, you can use those or the one we just used. And this is the script I used for the batch measurements, which is also just a shell script that counts to 50. And then your measurement should have finished. Why we do it this way, that we first let you figure out how to do it and then discuss it, is that the measurements will need some time and they should be finished now. So now you can probably download the JSON and look at it and figure out how to parse it. The shortcut is there's a script that I wrote that will do the parsing for you. It's in the Git that you downloaded. I just have the full link here. So please download your result, parse it, and then we convene again.
Maybe we can look at the raw JSON and show why it's not straightforward, because DNS actually has a buff, an answer buff, which is sort of DNS data, and that's what the measurements give you back. So
that was a trace route. Sorry.
Or we can also just go to the measurement we just had and go to the results.
Yeah, that is true.
Here. So you go to results, you just either download or do this URL preview. That's the other thing you can do. You just copy and paste that thing, just show it. You have a JSON prettifier.
Sorry.
So that's what it looks like raw, but maybe there's also a useful thing to actually do. There's browser plugins to make your JSON structures pretty. So if you
should we go to the pretty stuff?
Yeah, the pretty stuff is prettier. So yeah, this is the results set coming off of. So the first result coming out of this probe. The destination address is 192.168.0.1. So this is probably a probe that uses a local CPE as the local result. Time sync, so there were 10 answers. The DNS ID was this, no name servers, QD, what's QD? I forgot. DNS people, help me. That's not, is that the question count? Probably, one question. And so this is the interesting thing. And only if you're a real DNS protocol geek, even then you probably are not able to read this. But this contains the information. This contains all the 10 answers that we're looking for. Took 40 milliseconds, and the size of the packet was this. So this is the problem. That contains the information, and that's unparsed data. So you need a parser to actually get that. So that's why the prerequisite had DNS Python, so you can actually get that result out. And so that's why. So if you take a minute to actually download your results and get it through this parser. So 5 minutes.
Yeah, I think it's right. Okay, you got the same rule.
Yeah, no, that's nice.
Which line? 17. Yeah, I will come.
Show me
You looked at noise.
Yeah, I'm trying to use the command line. Okay. Which I never use. Okay, I want to resolve on the
Okay.
it's supposed to work.
Yeah.
So the documentation shows the command line after which is not very nice. Documentation which is not actually the tool.
But will not be the first one.
It's not your fault. No. It's not your fault.
Yeah. I think it might be that you need a fragmented JSON.
Yeah.
I see that error.
Oh, okay.
Everyone, maybe you need a fragmented JSON. Okay, you need a fragmented chase.
Okay. I do a quick bio break.
Yeah. So everybody that gets a weird list, not string, whatever error, you need a fragmented chasing.
So I get Python 3 complaining about Scheitle bytes.
About what?
I think it's Python 3 being can't convert bytes.
Okay. I guess Python did some updates.
So I don't know which version it is. This is 3.4.
Yeah, that's the Python fund.
Oh, is the header is actually the library.
It might also be that Atlas Sagan did some updating now.
Yeah, I've had issues with Python 3 and libraries. Is there a reason you want to force Python 3?
I just use Python 3. I guess you can do Python 2.
Because I know Costa has problems with 3. Really?
I used 3, so it's just.
Okay. Well, maybe I think you have an update on that.
But 3.4 is, I think I have 3.6 or now 3.6.
Ah, see, it worked with 2.7.
Then use 2.7.
No, now I want to know. Another big project.
Yep.
Maar kijk, het is goed dat het er zo uitkomt natuurlijk dan, hè? Ja.
It looks like in your answer you'll get some region-specific coding, and this actually is coding for US. So Ukrainian users will get the US. That's fascinating. Yeah, so but then, can we quickly go to your measurement specification? Can we also go to the my first reaction is the system made a mistake, so let me actually go to
And is it all measurements or is this just no, it's if you look at your measurements themselves, go back to the timeline. Yes. Okay. So it's not that. What could happen is that one of the processes will be actually while it says the method that you have started is Ukraine, it could be in the US. Stuff like that. Was it nice? Kind of the end user stuff. This is fascinating. Can we just use an example? If you give us a measurement ID.
Just that.
189 in the end. 189 in the end. Did you have it?
I still have, so I just have to.
189. Yeah. You want to just download the results and get it through your script online? Yeah, I think it's a useful exercise. So, yeah.
So I just pass this.
Because we go to the script.
Yeah. So familiar with this types of. Shall we continue?
Yes.
Okay, so I guess this is a good time to continue. Or do people have results? Who has results? Oh,
Good.
okay,
So I think the critical part was fragmented JSON, and then I think, sorry, unfortunately some people have some Python version that doesn't work or couldn't get a module installed, but we don't want to spend our lab on fixing Python. But I think it worked for the majority, and for the others, we are happy to.
Yeah,
look at it in the
you
break.
can actually see what it looks like here.
So I think what people probably did is just download the result as fragmented JSON in the browser. Then what the script does is it parses that JSON, parses the above, and prints you to std out. And then let's look at what do we actually see in those results, because that's quite interesting. So here we have a measurement from which country?
Ukraine.
Ukraine?
Yeah. So
very cool.
and this I'm totally fascinated by this measurement right now that Andrea did, because he picked Ukraine. But look, so in the NS you have like levels of interaction. What Apple actually does is they do a CNAME, so that's this thing actually is a different thing. So it's a pointer to another host name. So they and that thing actually resolves to US-courier-push Apple. There's US in here, and what we know, what Quirin found is that Apple actually uses region-specific codes for Scandinavian countries. It says EU scan, something like that. But so apparently, probes from the Ukraine, like the resolvers that are used in the Ukraine, actually go to US infrastructure. We don't know for sure. This is just a hint that we're getting, but I'm fascinated now. So my immediate reaction would be, I want to trace route to this IP address and actually figure out if the path actually shows me that this is actually going to the Ukraine. That, but to finish, you can just see 1, 2, 3, 4, 5, 6, 7, 8, 8 names, 8 IP addresses that the users in the Ukraine will actually be served as Apple notification service endpoints. So that's what this measurement says.
And I think, sorry, question.
I got the same US and I tried from Pakistan.
From Pakistan,
So
okay.
it could just be Arcola naming it incorrectly.
Sorry?
Because that's going to Arca DNS, right? That could
Yeah.
be Akamai naming it incorrectly.
That's possible, but
Because it's not Apple, like
so
Apple
if
is pointing
this
to
is still
optimize.
Ukraine, right?
It's
And if we
optimized.
continue, this is pop euro, which is more like what we would expect. If we go through the list, so probably some of your countries have that as well. These different letters here, which kind of indicate the region. So here some are Europe, some are US.
Yes, so from this, I mean, this is a lot of inference, and we actually need measurements to actually verify our thinking around this. This looks like US is just a fallback, it's just a default route of last resort. If we don't have anything specifically local for this, we'll just move it to the US, to our US infrastructure. That's what it looks like, but then again, we have the second part of the lab.
We'll figure that. Does anyone have something curious for his or her country? Or do they all more or less look like that?
I have one in China that is going to Australia maybe.
What does it say, the string?
Or APAC US.
APEC US? APEC US?
Yeah.
So APEC is typically Asia Pacific,
Yeah.
and US is maybe the fallback again.
AUS.
AUS, yeah. Then it sounds like Australia, yeah.
Yeah, APEC AUS.
SJC, San Jose,
Typically,
something,
yeah.
which
But-
is unusual for Iran, which you did.
SJC, wow.
So I mean, mostly it's US, but
Yeah.
one entry is just.
Mm-hmm.
See, simple DNS
Yeah.
measurement. Lots of. I mean, I'm fascinated by these results already. So.
So I think that really highlights the potential of doing this global DNS resolution, which took us not that much time, right? It's just some clicks in the API and you get a global view on how does this huge infrastructure work. And we already have a good discussion. Any more comments? Or then we'll move on. So then the question is, we have these region-specific CNAMEs, and then kind of now we have IP addresses, but are these all IP addresses now, or just some? Do we have to do more measurements? How do we know if we've captured all of the backend? Anyone have an idea? So kind of my view is if we resolve all 50 and we use all probes that exist, it's kind of as many as we will get. But if we just work on a country, obviously we might be missing some pieces. In the paper I did it globally and just used a lot of probes.
Or one thing you could do is repeat this 10 times, see if the distribution of things you get out of it is even. And if you keep discovering new things, that might be an indication that you've not reached the potential of the system yet.
That's the other point, that the DNS servers might give you different answers for each time you ask. So maybe you would ask 10 times or something, or however frequent, to see if you've got all. Cool. And then we say, okay, we figured out where these servers are. Now we want to know, coming back to that research question, like how many networks would you have to listen to see all those logins going to those servers that we just identified. So that's what we want to do traceroute measurements from. We want to say from the users, which way ever we simulate them, to those servers, what networks are typically in between. For that we use traceroute. And here please, as for DNS before, do a measurement strategy and think about, so you do traceroute, but think about which settings will I use for that traceroute. Traceroute also has a lot of settings, and please just play around with them, do your thoughts, and then we'll reconvene in some minutes. Think again also, which probes do I now use for the traceroutes? The same as for DNS, others, a subset, superset. And which targets will I use? You have a lot of IP addresses now. You traceroute to all, from all probes to some. Think about that a bit, coming back to the research question. So this is the part where you need to kind of figure out which kind of granularity makes sense to answer that question? I admit it's a bit more challenging, but does it make sense?
Does anybody have an idea already how they would want to specify this? Yeah.
No, I mean, I would just give you 5 minutes to think it through and then we discuss it. Or do you say you have no idea and 5 minutes won't help?
I think we need to speed up a little. That's also like
yeah.
We only have 20 minutes left, so.
So probably we won't. Yeah.
Yeah, maybe. See how far back I have that. Give the example.
Okay, good. I'm sorry, we are running a bit out of time, so we'll just speed up the discussion. Did anyone already figure out a strategy how to proceed with that rather complex task? You did?
Yeah.
You already discussed some interesting details, yeah?
So we just use all the probes.
All probes for your country?
And we start one measurement for all the probes to each of the targets that we found.
Every IP address you found in your...
Sure.
Yeah.
And then we found out which AS is being hit by the most probes.
Mm-hmm.
And then we just select how many AS that we have, like we order them from the ones that are most hit to the least. And then we just select as many as we want to reach the amount of eavesdropping that we want to achieve.
Mm-hmm.
Yeah.
Good. I think that's the...
Aggregate the prefixes as well.
But that will cost you a lot of credits. that strategy definitely works, yeah. And you're already saying...
Aggregate the prefix, so you get 1/24, then probably just...
You're saying aggregated /24. Which IP do you use? /24?
0.
Maybe. So I just picked one random one that I had actually seen in that /24. But
Okay. I would pick the one that was seen the most, but yeah.
Yeah. But
Yeah,
yeah.
that's and another thing, like 24s, that's typically like the smallest unit of routability, but you could see weird local effects on, like at an IXP, they might actually announce a 25, so they're actually sure that it won't propagate beyond the people that, so there might be all kinds of weirdnesses. Or you could look in BGP, actually see, if you look these up, if you go to stat.ripe.net, you look up these individual IP addresses, you'll, for the ones that I looked up, I saw they're in /20s, so you could actually also just measure /20s. And so there's a lot of things you can do to actually minimize the number of measurements you have to do. But you'll lose some accuracy. You'll have to make some assumptions to actually do that.
Yeah. Should we run through what details to run for the trace route? What details to enter? Yeah.
So actually, I was gonna say among the results that we have, we can find the IP addresses on the same network. If we find the same network, that means that we can observe that network, because in that case it's possibly going through some kind of a router and then to a computer, which means that the actual activity is there, so that if we observe that, we can get the activity, all the activity from those networks. Is that the case?
I could not follow that.
Yeah, I'm not sure I understand.
Okay.
Can you reformulate?
So from every answer we have 8 IP addresses here from the results that we get. When I look at these IP addresses, I see some of the IP addresses from the same answer has the same network name, except the last 2-3 digits.
Yes.
So I'm guessing, I'm saying that they are on the same network. So this probably the IP address that I should observe to get the activity.
Yeah. So that's the /24 that you're describing, or to say the last 3 digits are the only ones.
So the last octet, you just chop it off and pick either a random one or a 0 or a 1, and then do measurements to that. Yes.
Good, then let's quickly run through how we would do the trace route. So target, we would pick an IP address depending on some of the strategies discussed. Timeout, I would leave it default.
Yeah.
I don't see a reason to change it. Then what protocol do you use? What I actually did, APNS uses TCP 5223 for login, so I took that. It shouldn't make a big difference, I believe, but it felt more precise.
The nice thing about that is actually if you have a responding service or a service that should respond, then it's nice to say TCP port, and then actually I think it's in the advanced options, right, where you specify the port. Yes, here's the port. So then you're guaranteed to actually get an answer from that service under normal operations. So lots of hosts on the internet don't respond to pings or at TCP port 80, you have to have a web server running on something, right? So having an endpoint that reacts is really useful in these types of. The other thing where it's useful, if you're actually going to look at latency, is that some people treat ICMP traffic different from TCP traffic. And then if you're looking at latency type things, then that type of, do I do a TCP trace route or an ICMP trace route, that really makes, can potentially make a difference, according to folklore of network operators who say we treat this packets differently. So we don't trust ICMP measurements, for instance. Or some say we prioritize ICP measurements because we know people are measuring our network and this makes our network look super good. So there's all kinds of weirdnesses there.
But so matching it to the service you're kind of measuring makes sense. I already heard you discuss like Paris trace route. I don't think we can go into the details of that, but that would be like the very thorough way of doing it, to say I'm not doing one trace route, I'm doing a set of trace routes to get all possible paths to the target. But for that, you would need to do a recurring measurement with some changed settings.
Yeah.
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 Good. Then let's quickly run through how we would do the trace route. So target, we would pick an IP address depending on some of the strategies discussed. Timeout, I would leave it default. interesting stuff, but I think not in our time budget.
I think for the probe selection, you can actually do something really interesting, which is reuse the sets from a measurement. So for the first measurement ID that you had, where you had like 10 probes selected, you had a list of IP addresses there already. You could, if you click here, say that measurement ID, you could actually, say the measurement ID that you selected for the DNS measurements. So it's the same set of probes where you do the DNS measurements that actually do the trace routes. So you get a more confined set. I think that's like, I could make the argument in a paper that that's a good way to do this.
Yeah, and I think what we haven't discussed, but which would also be a way to make it more thorough, is to say you only measure on a target IP from a probe that has actually seen it. Otherwise, you might get some bias if you measure from some probe that didn't see some target IP. You might go through some networks that in reality measurements or the traffic wouldn't go through. So that would be kind of to say for each probe, which IPs did it see, and then kind of calibrate it to also factor that in. Another thing which we could discuss is if you select all the probes in a country and you kind of want to say how many networks do I have to observe to see that percentage of users. Probes don't necessarily represent the user base. There might be a heavy bias. There's a nice example here, I think.
Yeah.
The access for order.
Yeah, so Access for All is a really techy network in the Netherlands. And this is an example of where RIPE Atlas is heavily biased. So they, according to the APNIC data that we have, they have like roughly 3% of the end user market, whereas Ziggo has 26% of the market, and both have 80 probes. And this is because they do IPv6, they do all the technical stuff, and these are also the people that deploy RIPE Atlas probes. So that's a type of bias that you have to keep in mind, that it's not RIPE Atlas probes in a country represent the user base in a country. That's maybe a first order assumption is yes, that's the case, but then if you go look deeper, you always find these types of biases, which in itself is really interesting, I think. So,
but I think to make that refined, you wouldn't just count the paths for all probes, but you would kind of scale it by user base or something to give you a more precise percentage number. Good. I think we will skip the trace route parsing. that will not be doable in 5 minutes. Maybe just as a quick discussion, so the trace route is just a JSON, we've seen it before, it's actually fairly simple to parse. I think I just used rate JSON parsing as well. And then we would have to map it to IXPs and autonomous systems. There's various ways to do it. I used the KIDA prefix to AS and the peeringdb/trace route IXP subnets, but there are better ways to do it, but I think that will be a good start. And we will just skip it for now. If you're interested, the slides are in GitHub, so you can
maybe we can ask, do people have measurements, the trace routes running already? Yeah? Okay. So you actually have something that you could run this script on and see what it actually looks like.
Yeah.
So
you have the slides, so please run it if you want to. And yes, this is kind of what we would have discussed. So it wasn't that surprising. Yes, the internet is quite central, and if you get access to 10 big networks, you have 80% of the users, either on a global scale or on a country scale. But for some countries, it might be different. I heard Argentina, I think, basically everyone is going through the IXP. So it might be a bit different. So here you would maybe only need one network. It would be interesting to see it across the countries. So if you finish it sometime, feel free to send it back.
Yeah, so you were actually wanting to specifically have a pull request to the repository if anybody gets results. So then getting that table back for a specific country is really interesting, and also helps. And that's another thing that where a lab like this helps. It's just like verification of the measurement methodology. So other people also doing it, it becomes reproducible. It's got all the nice qualities that research should have.
So if you finish it, please follow those lines and send it. That would be really cool to kind of also have it on GitHub publicly accessible for everyone. Cool. I think we can go to the feedback and conclusion.
Yeah.
Everyone excited to use RAP Atlas? Any specific insights or comments you want to share? Did you like it? What was useful, not useful?
So about not just RAP Atlas, about the measurement. So there's a bias with the probes, but with respect to doing this resolving on the app, what Apple uses or common services use, such as for push notifications, do you think you're also being biased towards how the CDNs appear at different IXPs? Because most of the examples we saw was Apple pointing to a CDN and say, go there, and then CDNs doing this voodoo shit where they'll hop you around for the best delivery, right?
Yeah, but
so do you think the view of our network of where your paths are going to, or at which IXP and how we see is getting biased by how Akamai or Limelight is trying to appear at different?
But that's not bias. That's actual. This is how these services are created. So what Apple actually does is they use multiple CDNs. So they're multi-CDN. So they typically.
But then you have to also diversify the service, right? Because Apple pays a certain CDN. That doesn't mean that that's how the internet. That's for that service. That's how.
Yes,
Apple
but that's the research
that's
question. The research question is how many. Which networks would you have to be in to intercept this traffic for this specific service?
Okay.
So, but your research question was
like
different.
a little broader. So if you diversify Apple services and Microsoft services and a bunch of, you have like 100 services, and then you do this measurement, it would give you a much more wider view of how people are accessing.
Oh, accessing these types of services, yes.
Yeah, and where do their paths go? So for Apple, maybe I always go through this IXP, but say if I'm using some sort of a Google service, then that's not the path that I take, because Google creates.
No, that's exactly a big problem in, like, if people measure Facebook or Google, how do you measure Facebook or Google this way? I mean, it's so big and diverse, and there's multiple CDNs involved and all kinds of weirdness. So how to actually specify these things is a challenge already in itself.
Cool, thank you. Any more comments, questions?
Any challenges in using the system? Anything RAP Atlas could do better? So it's perfect?
Officially bug-free and perfect.
So for the fields that people were having trouble finding what it means, is there a way you can just hover on it and the jQuery thing pops up with the information? That's like a UI thing, but that would be very helpful.
Yeah, okay.
Liked it, yeah. Good, and you should all have like 950,000 credits left, so have fun. Thank you.
Okay, thank you.